What's up, guys? Today we are talking about Theorem 7.1, the Polygon Interior Angles Theorem. And we are pretty familiar with this idea, but now we're going to take it a little further and talk about a theorem based on this idea. So I think everyone in the class knows that if we add the angles, so these angles, there's a green angle, red angle, and a blue angle. If we add up the angles in a triangle, they will equal 180 degrees, right? So now we're going to have to ask ourselves, what if we have a different polygon, a different shape? What will those angles sum up to be? So let's look at a nice friendly square. Okay, and now the square has 4 sides instead of the triangle's 3, right? And we're thinking to ourselves, will these also add up to 180 degrees? Let's check it out. So the great thing about a square is, by definition, it has 4 90-degree angles, right? So we know that if we want to add these angles up, we have 90 plus 90 plus 90 plus 90, or 90 degrees times 4. 90 degrees times 4, and if we do that, that equals 360 degrees. So it is now quite obvious that the sum of the interior angles of different polygons is different. So if it has more sides, in the case of the square has 4 sides, it's going to have more angle measures. The angles are going to sum up to a bigger number. In this case, it was 360 degrees. So the triangle had 3 sides. So now let's explore this theorem. What this theorem states is that if, I'll do it in green, let's try green out. The number of sides is what's going to determine what the interior angles add up to be. So the theorem says that the sum, so if we add up, that's what sum means, the sum of the angles, and those are interior angles, equals n minus 2 times 180 degrees, times 180 degrees. Now you should be thinking to yourself, what the heck is n? Where did this thing come from? N. What are you in? So n, I'll write that up here, n equals the number of sides. So for the square it's 4, for the triangle it's 3. And simply all we have to do is plug in the number. So for the square, this number of sides is 4. Subtract 2 times 180, that's 2 times 180. 4 minus 2 is 2. So 2 times 180 equals 360. So that works. Okay. That theorem tells us what the angles need to add up to. So let's try one more quick look here. Ooh, I lost my cursor. There it is. Let's look at a hexagon. So number of sides of a hexagon is 6. Let's go to purple. 6 sides. So n equals 6. So simply we plug in 6 for n. 6 minus 2 times 180 degrees. And 6 minus 2 is 4. 4 times 180 degrees. And that equals 720 degrees. So the interior angles, if we added up all these blue angles, 1, 2, 3, 4, 5, 6 angles, if we added all of those up, they would have to add up to 720 degrees. Let's do a quick example problem. Example problem. So here's the problem. We have how many sides? N equals what? N equals 4. There are 4 sides, right? 4 sides to this thing. So that means we can add up all of these angles. So I'm going to start with 127 degrees, and I'm going to work this way. It doesn't matter what order you go in. I just want to make sure I include all of the angles. So 127 degrees plus this next angle measure is 5x plus 3 degrees. Next angle measure is 88 degrees. And finally, we have 10x plus 7 degrees. Because it's a 4-sided polygon, we know, just like in the square, right, just in the example of the square, we scroll back to our square, there's our square, it's going to equal 360 degrees, right? It's going to have to sum up to 360 degrees, so we'll put that in there. So now at this point we can combine our like terms, things that are the same. So let's circle those. Here we have a 5x, and we also have a 10x over here. We can add those together, right? X's add to x's. So 5x plus 10x is 15x. Then we can also add up all these other numbers. So these are like terms as well, right? They're just numbers. A bunch of different angle measurements. We can add those up. So 127 plus 3 is 130, plus 88 is 218, plus 7 is 225. So I'll go back to my blue here. Plus 225 equals 360 degrees. And then finally, we just do our algebra moves. Subtract 225 from both sides, always from both sides. Sorry, my handwriting is not very good on the computer. So we're left on this side with 15x, and on this side 135. Last step is to divide both sides by 15. And we should find that x equals 9. So this is just one example of how we can use the interior angles theorem for polygons to solve a problem. All right, and then here's the last thing. In class, I may or may not ask you which sticker I placed on the board at the end. So if you can remember what this sticker is that I just placed down, you will get credit for watching this video. Take it easy. We'll see you in class.